today's lesson, we are going to be looking at the exponent laws. We're going to review the laws that you learned from last year in grade 9. So, this here is a power in which 4 is the exponent and 2 is the base. And the exponent is telling us to multiply by the base 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we can evaluate a power through repetitive multiplication. The tricky part comes with a negative sign. For example, let's look at C. The negative is inside the brackets. Therefore, it is taking -2 and it is multiplying it by itself 4 times. -2 is part of the base. And since you have an even number of negatives, 4 negatives makes a positive. Whereas if the negative is on the outside of the base, this is not in brackets, therefore this is read negative multiplied by 2 to the power of 4. So you do 2 to the power of 4 and make negative, or you could put a -1 out there and think it's 2 to the power of 4 multiplied by -1. And that is -16. So where the exponent falls, or where the negative falls, makes a difference. When you have an odd exponent, it doesn't make a difference. So 2 to the power of 3 is 2 times 2 times 2, which is 8. Whereas -2 to the power of 3 is -2 to the power of 3, which is -8. And -2 to the power of 3 is 3 negatives. And 3 negatives creates a negative. So you can see a negative not in the brackets and a negative in the brackets creates a negative. Same answer when the exponent is odd. Alright, so let's take a look at our first law that you learned last year, the product law. So if you have 8 to the power of 3 multiplied by 8 to the power of 2, typically in math, which we always have to do, is we always have to follow the rules of BEDMAS. And BEDMAS tells us we always have to make sure we do exponents before we multiply. So we'd have to type in 8 to the power of 3, get our answer, 8 to the power of 2, get our answer, then multiply. We get large numbers, but we could do it. So what we could do is, well, let's look for a shortcut when the bases are the same. Why do the bases the same matter? Because 8 to the power of 3 is 8 times 8 times 8. And then we're multiplying by 2 8s. Well, when the bases are the same, you can see, isn't this just the same as 5 8s being multiplied together? So we could just write this as 8 to the power of 5. So if the bases weren't the same, like if that was a 7 to the power of 2, we couldn't do that, right? But since the bases are the same, we can do that. So the rule is, if the bases are the same, we can add how many of the bases we have. And the exponent tells us how many we have. We have 3 8s multiplied by 2 8s, so altogether we have 5 8s. Or in other words, if I have 3 A's and 2 A's, altogether I have 5 A's. Or my rule would be, when the bases are the same, we would add the exponents. Let's try a couple examples. Let's try this one. So if my bases are the same, I can add the exponents. If my base is not the same, I cannot. So I write it like that. I apologize, my pen is being sensitive, so it is writing funny today. Okay, over here, since all of them have the same base, we can just keep the base and add. 3 plus 5 is 8, plus 6 is 14, right? If there's no exponent, it has an exponent 1, right? So we would go 2 plus 3 is 5, plus 1 is 6. And you have 6 of them. If our base is numerical, we just keep that base. The base is 2. And if our exponent has a variable in it, well, we can add exponents with variables in it. If they are like terms, if we get x plus 3x, then we just combine like terms. This gives us 2 to the power of 4x, right? Or if I had something like this in h, I would have 5 to the power of 3x plus 2 minus x, which would give us 5 to the power of 3x minus x is 2x, and then plus 2. That's the best I can do. I can't simplify that exponent anymore. Alright, the quotient rule, similar to the product rule. This time we're dividing. So if I have 3 8s, and I'm dividing by 2 8s, then I am canceling if they are the same factor. So if they're the same factor, we're canceling 2 x's out of the 3 x's. And since you're canceling, you are losing them or removing them or taking them away. So I am taking 2 eighths away from the 3 eighths, and I'm left with 1 eighth. So when you're dividing, the rule is we subtract the exponents, and you're left with 1a, which I would just write as a. I don't need the exponent 1. Or my rule would be keep the base, don't subtract the base, you keep the base, you only subtract the exponents, because the exponents are your counting of how many bases you have. So you're subtracting how many you have. So in this question, let's look at B. If you're dividing, you would just go 7 minus 3 is 4, right? Or if I was to look at this question here, working left to right, I would go 7 divided by, or a to the power 7 divided by a to the power 3 is a to the power 4. And then when you multiply, you always have to work left to right, you would get a to the power of 10. Okay? If you have it written in this order, so this fraction bar means to divide, you have to look for like bases. I have my x's. X to the power of 5 divided by x is 5 minus 1, which is 4. Y to the power 7 divided by y to the power 3 is y to the power 4. Subtraction. Z doesn't have a like base, so it remains as z. Alright, same thing if you had numerical bases. Let's look at h. You would get 2 and then 5x minus 3x. Oh, I can collect like terms. 2 to the power of 2x. Being careful with division, because division is subtraction, I would get 4 to the power of x, subtract, and when you're subtracting a binomial, you're subtracting two terms, we have to make sure we subtract both of them, right? So we're going to get 4 to the power of x minus positive x, which is minus x, and minus negative 1. Well, subtracting a negative becomes a positive. So I'm going to get 4 to the power of x minus x is 0, 4 to the power of 1, which is just 4. All right. If I looked at D, I would get a to the power of 8 divided by a to the power of 8, which gives me a to the power of 8 minus 8 is 0. So what we're going to learn now is, what does that 0 exponent mean? What does a to the power of 0 mean? And I'm going to teach you that a to the power of 0 is 1. And the reason that a to the power of 0 is 1 is because it doesn't really matter what you start with. If I had 8 to the power of 3 divided by 8 to the power of 3, I know that anything divided by itself, right? 5 divided by 5, 10 divided by 10, it doesn't matter what two things I'm dividing, if they're the same, I get 1. Okay? Or, so, when you're dividing and you get a 0 exponent, it means everything canceled, right? Everything canceled and you're left with 1. So our rule is, anything to the power of 0 is 1. It's no longer a power, it is just a value of 1. Right? Because if I had 9 to the power of 5 divided by 9 to the power of 5, I would get 9 to the power of 0, which is 1. Just know it's 1. Even if the negative's inside, you'd be like negative 9 divided by, or to the power, or divided by negative 9. Well, a negative divided by a negative becomes a positive. Sorry, my pen is really being touchy here. The negatives would become positive. So, if the negative's in the brackets, this is still positive 1, right? Because all of the negative 9's cancel to be left with a positive. But if the negative is not inside the brackets, then it looks like this, right? All of the 9's canceled, but there was this negative out front, so it remains negative 1. You do 9 to the power of 0 first, and then make negative. Our last three rules are our quotient rules. Okay, so if you're multiplying and raising it to the power, well, 8 times 7 to the power of 3 is the same as 8 times 7 multiplied by 8. Oh, my pen keeps stopping here. Let's try this up here. Multiplied by 8 times 7. That is really being funny today. Multiplied by 8 times 7. So I have 8 multiplied by 7 3 times. Well, if it's all multiplication, we can just rearrange the order. It's the same as 8 times 8 times 8 multiplied by 7 times 7 times 7, right? Because it doesn't matter the order of multiplication. So this is really just 8 to the power of 3. And again. go, 8 to the power of 3 multiplied by 7 to the power of 3. Okay, so the rule is when you're multiplying, the 3 just goes to each factor. The m would just go to each factor. Now, this rule is important. That is really messing me up. This rule is important, anyway, you get the idea. Is important to not get mixed up with addition. If you are adding, the 2 does not go to both. This is a product rule. This is not a sum rule. This only works with multiplication. Same thing with division, right? If I have 8 over 7 multiplied by itself 3 times, it's the same as 8 3 times over 7 3 times. If you have a quotient, the 3 just goes to both, right? Now, please remember, if it was subtraction, you cannot do that. That does not work. There is no power of addition and there is no power of subtraction rule. It's only with multiplication, division, and last power of a power. 8 to the power of 3 raised to the power of 2 is 8 cubed twice, right? Well, if I have 8 cubed twice, I have 2 groups of 3, right? 2 groups of 3 is 6. Or in other words, we can just say 2 groups of 3. And so you can multiply the exponents when you have a power raised to a power, because you are, a shortcut for multiplication is repetitive addition. 3 plus 3 is 6, or 2 times 3. So in this case, it would be 3 times 2, which is 6, or a to the power of m times n. So the only time you multiply the exponents is if you have a power raised to a power. Let's practice a few. So this is 2 times a, right? So that is a product. Since you have a product raised to a power, the exponent has to go to the 2, and it has to go to the a. And since 2 is numerical, I could evaluate 2 to the power of 5 now, right? A to the power of 5 I don't know, and I don't need to write the multiplication sign. I just wrote that to show you. You can just write it like this. This becomes 32a to the power of 5. So here, this becomes 3 cubed multiplied by x to the power of 6. Or in other words, 27, not 9. It's 3 times 3 times 3, x to the power of 6. Here we have negative 3 squared. Negative 3 times negative 3 is 9. The 2 goes to the a, and the 2 goes to the b. And here we have 3 negative 2's. Negative 2 times negative 2 times negative 2. 3 negatives is still negative. Then I would get x to the power of 6, y to the power of 9. Right? You multiply the exponents. Since this is a fraction of division, the 3 goes to the numerator, which becomes 2 to the power of 3 multiplied by x to the power of 3 all over y cubed to the power of 3. You would multiply those. Okay? And we will do this last one over here. If you ever have, actually I'm going to skip that one, we'll come to that in our next video. I'll just jump on down to the next part. Actually, we'll just do this last one here. I would get negative 3 to the power of 2, which is 9, x to the power of 4, all over 5 to the power of 2, which is 25, and then y squared. All right, we'll come to a question like this in the next video.